will discuss another important topic, that is production possibility and profitable output levels. Now, it is important aspect, and it happens when the producer, suppose he is a commercial producer and his resource is limited, and within this limited resource he wants to produce the goods looking to the market price, the trend of market price. So it is very much important, and say it is obvious. Suppose for simplicity, a farmer, agricultural farmer, producer, he is near a city, so he has 1 hectare of land, suppose, and he wants to produce those goods which have a good market in the city. That means price is high in the city. Suppose he wants to produce 2 goods, goods A and goods B. So he will see whether price of good A is high or good B is high. If price of good A is high, obviously he will put more area under A and less area under B. That means he will produce more of A and less of B. So this way he will go on observing the market price and produce different quantities of A and B. So there will be different combinations of A and B according to market price. So there is certain assumptions that in doing so, because in economics, so assumptions are important, that the resource will remain fixed, his capital will remain fixed, and he will not apply, say, yield increasing technology every time, so that he will produce the combinations of goods without any technological bias. So these different combinations, if we plot in the graph, we'll get a production possibility curve. So this is the output, combinations of output, and optimum level of output combinations can be worked out, not out of so many combinations. So one combination will pay him the highest profit. So if we relate with return and combination of the goods, we'll get the most profitable level of the combinations. Now, let a producer has a fixed area of land and he wants to raise 2 commodities based on market demand. Then suppose area is the function of Q1 and Q2. So this is the best example in agriculture. So there may be industry also, separate industry, small industries, where they will produce looking to the market price. A is area, and Q1, Q2 are 2 goods to be produced. the total return is equal to P1 Q1 plus P2 Q2. That means quantity of Q1 multiplied by price of Q1, then quantity of Q2 multiplied by price of Q2. So when you will sum up this gives the total return or total revenue. B1 and P2 are market prices of Q1 and Q2. When market price will change, combinations of Q1 and Q2 will also be changed. Out of all, only one combination Q1 prime and Q2 prime will pay the highest return to the producer. So at E, the return will be the highest. So OQ1, if he produces OQ1 and OQ2, his profit will be the highest. Now what is at E, slope of production possibility curve and the slope of the ISO revenue curve is same. So this is the production possibility curve, and at point E, the production possibility curve and the ISO revenue line is tangent. So it is the point of equilibrium. Let area is influenced by two products, Q1 and Q2. Then A is the function of Q1 and Q2. R is equal to P1 plus Q1 plus P2 Q2. R is total revenue, PI price. Then equality constraints. P is the function of Q1 Q2 plus lambda times R minus P1 Q1 minus P2 Q2. So if we maximize, then it will be F1 minus lambda P1 is equal to 0. This is the first order condition. Then delta V by delta Q is equal to F2 minus lambda P2 is equal to 0. And lambda, delta V by delta lambda is equal to R minus P1 Q1 minus P2 Q2. The first order condition states that rate of product transformation is F1 by F2 is equal to P1 by P2. So this production possibility curve, sometimes it is also known as the transformation curve or frontier curve. So there is different concept, so or different name rather, that it is also known as transformation curve or frontier curve. So rate of product transformation is equal to price ratio. Slope of the production possibility curve is equal to the slope of the total revenue curve at this point of equilibrium. So the first order condition we have come across many times. Then second order condition is that the relevant bordered Hessian determinant be positive. So this is the bordered Hessian determinant, F11, F12 minus P1, F21, F22 minus P2, minus P1 minus P2, 0. So this should be positive. That means if we find out the determinant, then it is 2 times f1 f2 f1 into f2, then minus f11 f2 square minus f22 f1 should be positive. Now there is a difference. It is not the case of a joint product. So like wool and mutton from the same sheep. So it is not the case of joint product, but it is the combination of the products. In sheep, when it is reared for meat purpose, mutton, and also for wool. So the case is different. So in this case, it is different. Simply, the products are separated. We have to combine them at different levels. So the production function is not homohypelagic and needs extended analysis. So in joint products, it is homohypelagic, but in this case, it is not homohypelagic. So that's why it needs extended analysis. So with this, we have completed the production possibility curve and how to maximize the profit by raising two combinations. The one best combination of output with limited resource. So the frontier curve or transformation curve, and how it is generated, and what will be the best combination. So with this we conclude, and thank you very much for watching. Go on watching and please share. Thank you.